Another hello from West Virginia. Well, another hello from somewhere anyways. Okay, I know that you really care about joke of the day. That's what you're wanting as joke of the day, so let's get to it. So what is yours? But you know, it's used more often, or much more often, by other people. What's yours, but it's used more by other people? Your name. I know, joke of the day is the best, isn't it? Okay. But we are now going to take a look at solving systems of nonlinear equations by the method of substitution. So we know how to solve systems of linear equations by the method of substitution. Nonlinear is going to mean curves. Remember, linear means graphing a straight line. So nonlinear means we're going to have a whole bunch of equations that are going to result in curves. So we could do this by the method of graphing, but wow, that is really difficult. So we're going to go with those other shortcuts, the method of substitution, the method of addition, also called elimination, because it's much, much easier to deal with your nonlinear equations in this manner. So remember, when you have that system, that is a set of equations that can be solved simultaneously for a common solution. So you see I have a system right here, two equations. We're going to solve them together for the solution that will be a solution to this equation and as well a solution to this equation. So with that method of substitution, remember, mathematicians, we're not creative people at all. We call it like we see it. So method of substitution means I'm going to substitute in some way, somehow. And what I'm going to do is I'm going to substitute one equation into the other equation. So that means that to begin with, I need to solve one equation for one variable, which sounds an awful lot like the method of substitution for those linear systems, and it is an awful lot like the method for linear systems. But after we take one of those equations and solve it for one variable, notice in this system that's already been done. I already have this equation solved for y. And so remember, that means that y is all of this stuff. Well, if that's the case, then I should be able to take all this stuff and plug it in everywhere I see a y. And remember, when we talked about our systems of linear equations, we said don't ever plug back into the one you already rearranged, because you're working with a system, and if you plug it back into the one you rearranged, you're not working with the system. You're working with just one of the equations. So what I'm going to do is, once I've got that variable by itself, I'm going to substitute this expression into the other equation. And remember, when in the notes for the system of linear equations, I put that in all caps because it was very important. Always substitute into the other one. So what I'm going to do then is I'm going to take all this and I'm going to plug it right here where I see that y. Now previously it was x minus the y. Now it's going to be x minus all this stuff. So to remind myself that I'm subtracting all of it, I'm going to put a parenthesis around it. Now, remember, when we have one variable, we can solve for this one variable. So we're going to solve this new equation for that remaining variable. But notice in this case, I have a quadratic. So I might need to use my quadratic methods. And those quadratic methods are, I can factor it, I can complete the square, I can do the quadratic formula, I can do the square root property if all I have to do is take the square root of both sides, which is not going to happen here. But factoring or the quadratic method are probably going to be my best ones. And let me tell you, if this thing will factor, that is the easiest way to go. It's actually faster than the quadratic formula if it'll factor. So let's see what happens with this. First and foremost, I know I need to distribute that negative through. So I will have a negative x squared minus 1. And then I know that with the quadratic, I got to get everything to one side. So I could slide this negative 1 over here. But notice that that x, that my highest power on the x is negative. We don't like that. So instead what I'm going to do is slide all this over here so that that x squared, the highest power on the x, will be positive. So when I slide everything over, that puts a 0 on that left side. And then I'll have x squared minus x. Notice I'm going to add 1. And when I add 1 here, then it cancels out. And I'm sorry, that should be a minus x. But anyways, plus 1 cancels out to be a 0. So here's the equation that I have. And like I said, I can go with the quadratic formula, but I'm here to tell you, if that thing will factor, that is the much easier way to do it. So what I'm going to do is attempt to factor this. And remember, when you factor, you first look to see if there's something common that you can divide out of every single term. And sure enough, I can divide an x out of both of them. So I'm going to divide that x out. That will leave me with x minus 1. And remember, once we factor, with quadratics, we're going to utilize our zero product principle, and the zero product principle says if I have two things multiplied together to get a 0, One of these two has got to be the 0. So either this x right here is the 0, or the x minus 1 is the 0. Now if that x minus 1 is 0, I'm going to add a 1 to both sides. That tells me x is a 1. But remember, this is not my solution because my solution is going to be a point in the 2D coordinate plane. I just now know I've got 2 points, one with an x coordinate of 0, the other one with an x coordinate of 1. So I need to figure out the y coordinates for each one of these. So at this point what I'm going to do is I'm going to say, well, if this x is 0, that means I can take that 0 and I can substitute it back in here or here, either one, and figure out what the y value is. So what I'm going to do at this point, now that I've figured out what that remaining variable value is, I'm going to substitute that value back into the original, and then I'm going to see what my answer actually is. I'm going to go with the top one just because I don't feel like dealing with a squared value, but you could certainly plug it into the second one. So I'm going to take this 0, I'm going to plug it right up in here, and when I do, I'll have 0 minus y equals negative 1. That gives me negative y equals negative 1. And if I divide both sides by a negative, that tells me that y is a 1. So that gives me a point of 0, 1, and that's going to be one of the solutions. So now I can say, okay, if x is 1, I can plug that again here or here. I'm going to choose the top one. When I plug it in there, I get 1 minus y equals negative 1. When I subtract that 1 on both sides, I'm going to get y equals negative 2. And when I divide both sides, I'm fine. When I divide both sides by a negative, I get y equals 2. So that gives me the second point, and in that second point, my x is 1, my y is 2. So it appears that my solution set, and I'm going to use braces to express that this is a set. It's a set. Now previously when they were linear, we only had 1 point in our solution set. Now we actually have 2 points in our solution set. So remember, your solutions, it might be 1, and if it is, your solution is a set, or the solutions are a set. So here's my answer, but remember, this needs to work. Both of these points need to work in both of these equations. Previously, when we had linear equations, and we only had 1 point, we would take that 1 point, we'd plug it back in here, and we'd plug it back in here, and if it worked in both, it was good. It was a solution to the set. I just need to do that for both of these. So I need to take this 0, 1, I need to check it in here. So I have 0 minus 1. Well, 0 minus 1 is a negative 1. Okay, it works in that one. Now let's check it down here. Put a 0 here. 0 squared is 0. 0 plus 1 is 1, which is exactly what I would have plugged in there. So I'm creating truth in both equations with this 1 point. This point is definitely a solution to the set. Now let's check this one. Take the 1, plug it in here. Take the 2, plug it in here. And 1 minus 2 is a negative 1, which is exactly what I wanted to get. So it's a solution to that one. It needs to be a solution to this one as well for it to be a solution to the system. So put the 1 in here. And 1 squared is 1, 1 plus 1 is 2, which is exactly what I would have put right there. So it creates truth in that one as well. So both of these points are in fact solutions to the system. And so very, very important, let me add this to it, that we need to check the solutions in both equations because it needs to work in both. If it only works in one equation, that's great. It's a solution to that equation, but it's not a solution to the system. All right, so you know that I like to have lots of examples for you to feel very comfortable with this stuff. So I've got 4 more examples for us. Let's take a look at this top one. Now remember, method of substitution means we're going to substitute one into the other. That means take one of your equations and get one of the variables by itself, and it doesn't matter which one you work with. But notice here, half our work is done. Yes, I love it when that happens because both of them have a y by itself. So that means that we can either substitute all of this up here or all this down here, and it doesn't matter. So I'm just going to take all this, plug it in there. Basically, I'm setting the 2 equations equal to each other. And when I do, I'm going to get an x squared plus 4x plus 5 equal to x squared plus 2x minus 1. And now I'm going to solve that quadratic, which means slide everything over to one side. Now, when I subtract x squared here, and subtract x squared here, the beauty is those are going to cancel out completely. And I'm left with a 4x plus 5 equal to a 2x minus 1. And now what I'm going to do, okay, it's down to linear. So I'm going to get all my like terms on one side. I'm going to get all my variables on one side, constants on the other. So I'm going to subtract a 2x, and that will give me 2x plus 5 equal to -1. I'm going to subtract the 5, and when I do that, I will end up with 2x equals -6. And when I divide by 2, I get x equals -3. So it appears that there is only one solution to this system and not more than one. But now that I've figured out what the x value is, I need to figure out what the y value is. So I'm going to take this -3 and I can plug it either here, and solve it with that one, or here, and solve it for that one. And it really doesn't matter which one I use. So I'll use the bottom one. It doesn't matter at all. And when I take that -3 and plug it in here, that means -3 squared plus 2 times -3 minus 1. Order of operations says do your exponents first. -3 squared is 9. And then do that multiplication after that. And 2 times -3 is going to be a -6. And now working from left to right with the addition and subtraction. So 9 minus 6 is 3. 3 minus 1 will give me a 2. I know that the y coordinate for that point is 2. So my one and only solution to this system is going to be the point -3, 2. And that's the only one. But remember, I do need to check this in both of those. So when I take that -3 and put it in here and square it, -3 squared is 9. Put that -3 in here. 4 times -3 is -12. 9 minus 12 is a -3, and -3 plus 5 is 2. And when I put, yep, I was going to put a 2 right there. That created truth on both sides. Now let's check this in this one. -3 squared again is 9. 2 times -3 is a -6. 9 minus 6 is 3. 3 minus 1 is 2, which is exactly what I would have put in there. So yes, this is a solution to the system, and I do have the right answer there. All right, let's try one more. Now this one looks weird because notice that I've got these two being multiplied together. But remember, with the method of substitution, I'm going to substitute one into the other. Doesn't matter which one that you get by itself. So I think what I'll do then is I'll take this one, I'll slide all this over and get that x by itself and plug that into this one. Certainly could have divided by an x here and then get a -12 over y and plug that in there. But what would happen is, oh no, plug it in here. But if I do that, then I have a -12 over y. I have a y in a denominator that's very difficult to work with. And if I would have divided by y and got that x by, or sorry, divide by x and get the y by itself, then that would put an x in the denominator down here when I substitute it in. Having variables in the denominator is a little bit challenging to work with. So I think it would be much easier to take this and, like I said, let's just rearrange it and let's add that 2y to the other side and let's subtract that 14. So that gets the x by itself, and now I can take all of this and I can substitute it right in there where that x is. Now this might feel funny, but notice that it's x times y. X is now all of this. So it's going to be all of this times y. And now what I'm going to do is I'm going to distribute my y through, because what I will end up having is a quadratic. Because 2y times y is 2y squared minus 14y, and yes, I do in fact have a quadratic. So I'm going to get everything on one side. I'm going to add that 12 to the other side, giving me this. And now I'm going to attempt to factor it. What I am noticing is that every single term is divisible by 2. So I'm going to divide every term by 2, giving me y squared minus 7y plus 6 equal to 0. And like I said, you can use that quadratic formula if you want, but I'm telling you I'm going to get there faster if it factors. So I'm going to attempt to factor it. I've already divided out everything I can possibly divide. And now this back sign tells me my signs are the same. This tells me both minuses. I know that this splits up into the front slots as y and y. And I'm going to split my 6 up into the back slots. And I want two numbers that are going to multiply for 6 and add for 7. That's a 6 and a 1. Sure enough, out here I'll get a -y, in here a -6y. That does give me the -7y. So I know that this is factored correctly. And remember, my zero product principle at this point says if I've got two things being multiplied together to get a 0, one of these two's got to be the 0. I have this parentheses times this parentheses. There's the two things being multiplied to get a 0. So either this y minus 6 is the 0, and if that's the case, y is 6. Or this y minus 1 is the 0, and if that's the case, y is 1. But remember, what that's telling me is I have two solutions to my system. One solution has a y-coordinate of 6, but I don't know the x-coordinate. The other solution has a y-coordinate of 1, but I don't know the x-coordinate. So I need to go back and I need to figure out what those x-coordinates are. So let's take this y equals 6 and let's try to figure out what that x-coordinate is. Now I can take that 6 and I can plug it in here, here, or I can even plug it in here. Notice if I plug it in here, then what I have is y times 6 equals negative 12, which is basically x times 6 equals negative 12, which is basically 6x equals negative 12, and if I divide by 6, I get a negative 2. So that tells me that one of the points as my solution is negative 2 comma 6. Now I'm going to figure out the other point. With that one, I knew that the y was 1. So here again, I'm going to take that 1. I can either plug it in here, here, or even over here. I'm going to go with this one again because that was x times 1 equals negative 12, which is basically x equals negative 12. Well, there it is. X is negative 12. So that means that my second solution is going to be negative 12 comma 1. And there are the solutions to the system. Remember, I need to check both of those in both equations. So I'm going to take the negative 2 and put it here. I'm going to take the 6 and put it here, which would be negative 2 times 6 is negative 12. It's exactly what I wanted. Now I need to check this one down in here. So x being a negative 2, y being a 6. Well, negative 2 times 6 is negative 12. So I have negative 2 minus 12 is a negative 14. Negative 14 plus 14, yes, it's 0. That works. Now let's check this one. Because I know this is a solution to the system, let's see if this is a solution to the system. So make my x a negative 12. Make my y 1. Well, negative 12 times 1 is negative 12. Yep, that works. But this needs to work in the bottom equation to be a solution to the system. So make my x negative 12. Make my y 1. Negative 2 times 1 is negative 2. Negative 12 minus 2 is a negative 14. Negative 14 plus 14, yes, it's 0. It cancels out. So these are, in fact, solutions to the system. Okay, we've got 2 more examples to get through. Okay, so in our fourth example, once again, method of substitution means I'm going to take one of the equations, get one of the variables by itself, and substitute that into the other equation. I don't know about you, but I'm looking at this going, I think that top equation is going to be the easiest one to rearrange. So let's rearrange it, and it doesn't matter which variable you get by itself. So I think I'll get the y by itself, meaning I'm going to subtract the x. And now that I have the y by itself, that means I'm going to take all of this, I'm going to plug it into the other equation everywhere I see a y, but notice I see a y in 2 spots. So this is going to get crazy because that y squared means I'm going to take all of this and square it. So now I've got a whole lot of stuff going on, but I am down to only one variable. So I can solve this for that one variable. So what I'm going to do, remember, order of operations says let's square this first. And when I square that, it's going to mean a negative x minus 3 times another negative x minus 3. And I'm going to FOIL that, or if you prefer to call it the extended distributive property, as I like to call it. And when I FOIL that, I'm going to get an x squared plus 3x plus another 3x. Outside I get a 3x, inside I get a 3x, and in the back, negative 3 times negative 3 is going to be a positive 9. And now I am ready to combine up my like terms here before I distribute the 2 through. So when I combine up my like terms here and here, I get a 6x. And now I'm ready to distribute. And I've got some distribution to do on both sides, so I'll go ahead and do that on both. So I will distribute my 2 and get a 2x squared plus a 12x plus an 18. Over here I'll get a negative 12x minus a 36 plus an 18. And I'm ready to combine up my like terms. So these two will combine to be a 3x squared plus a 12x plus 18. And then over here, these two will combine to be a negative 12x minus 18. Notice it is a quadratic, so I've got my 4 quadratic methods to use, but regardless, I need to slide everything to one side. So I'm going to add that 12x, and when I add 12x to both sides, I get a 24x And I'm going to add that 18. And when I do, I get a 36. Now, notice that every one of these terms is divisible by 3, so I'm going to go ahead and get rid of that factor of 3 from each and every term. And now I can either factor it, I can complete the square, or I can do the quadratic formula, and I'm here to tell you if that thing will factor, it's faster than quadratic formula. So there's nothing more common that I can divide out. I'm headed for that double parentheses. This tells me same signs. This tells me both pluses. Front slots are going to be x and x. I want two numbers that will multiply by 4 and add up to be an 8. Multiply to be a 12. My apologies. Multiply for a 12, add for an 8. That's a 6 and a 2. Sure enough, out here I get a 2x inside a 6x. That does give me the 8x that I wanted in the middle. So now either the x plus 6 is the 0 or the x plus 2 is the 0. Now if x plus 6 is 0, x is negative 6. If x plus 2 is 0, x is negative 2. And remember, I'm looking for a solution to this system. So what I do know is one of the points has an x-coordinate of negative 6. One of the points has an x-coordinate of negative 2. I need to figure out the y-coordinate for each of these. So I'm going to take that negative 6. I'm going to plug it back in here somewhere. Easiest thing is go for that top equation. So I'm going to make my life easy. I'm going for the top. I'm going to take that negative 6 and plug it right here. When I do, I get a negative 6 plus y equals a negative 3. And when I add that 6 to the other side, I get y equals 3, giving me a solution of negative 6 comma 3. And now I'm going to work with the negative 2, and I'm going to take that negative 2 and I'm going to put it right in here. So I get a negative 2 plus y equal to a negative 3. And when I add that 2 to the other side, I get a negative 1, giving me another solution of negative 2 comma negative 1. And this is my solution set. So, I'm going to clean that up for you a little bit. That's really sloppy. My apologies. Negative 2 comma negative 1. There we go. Now remember, if these are solutions to the set, they should work in both equations. So let's test this in the top equation. So I'm going to take that negative 6 and put it here. I'm going to take that 3 and put it here. Negative 6 plus 3 is a negative 3. That's exactly what I wanted. Now I need to test it in the bottom equation. Take that negative 6, put it in here. Negative 6 squared is a 36. And take that 3 and put it here. 3 squared is 9. 2 times 9 is 18, so I have 36 plus 18. And when I put the 3 right here, 12 times 3 is going to be a 36. Notice both sides have 36 plus 18. So I know that it is going to be correct. So this is definitely a solution to the system. Now let's test this one out. Take that negative 2, put it right here. Take that negative 1, put it right here. Negative 2 plus negative 1, yep, it's a negative 3. Now let's put these in the bottom equation. Take that negative 2 and put it here. Negative 2 squared is 4. Take that negative 1, put it in here. Negative 1 squared is 1 times 2 is 2. And now let's put those in here. So take that negative 1 and put it here. That gives me a negative 12. And put the negative 2, oh, no, I don't need to put the negative 2 in there. Well, 4 plus 2 is 6. Negative 12 plus 18, it's 6. So I know that both of these are solutions to both equations, therefore they're solutions to the system. Okay, we've got one more. This is the last one. Okay, here we are on the last one. And remember, with the method of substitution, get one of those equations with one variable by itself, and it doesn't matter which one you work with. I don't know about you, but it looks to me like that top one's the easiest. And it looks like the easiest thing to do is to get the y by itself. So I'm going to subtract a 2x from both sides. And remember, what that means is now y is all that stuff, so I can take all of this and I can plug it. Now remember, plug it into the other equation. Never plug it back into this one, because if you plug it back into the one you just rearranged, you're not working with a system, you're only working with one equation. So I'm going to plug it into the other one. Now when I do, I have x plus 1 squared plus the y is now all of this. Negative 2x plus 4 minus 2 squared. Okay, so now what I'm going to do is I need to square these, but I'm going to combine up my like terms before I start squaring anything. But the beauty is I am down to one variable. Now 4 minus 2 is a 2. And I am down to one variable. So I'm going to square this, and remember, squaring that means that I'm going to multiply it to itself. I'm going to end up either extended distributive property or FOIL, whatever you want to call it. And I'm going to do a similar idea right here. Squaring it means it times itself. So once again, either FOIL or extended distributive property, whatever you want to call it. Now when I FOIL this, x times x is x squared. On the outside here, I will get 1x. On the inside here, I will get 1x. And in the back, 1 times 1 is 1. Now, here, negative 2x times negative 2x is a positive 4x squared. On the outside, negative 2x times 2 is a negative 4x. On the inside, 2 times negative 2x is a negative 4x. And in the back, 2 times 2 is 4. And so now I'm ready to combine up all my like terms. So I can combine up my x squared and my 4x squared to get an x squared, 5x squared that is. Now I can combine up 1x, 2x, and 2x minus 4x is a negative 2x. Negative 2x minus 4x is a negative 6x. And now I'm going to combine up a 1 and a 4 to get a 5. And since it's a quadratic, what I'm going to do is I'm going to slide that 4 over and subtract it off, giving me this. So now I am ready to factor this thing, because if it will factor, that's the easiest way to go. And I'm not going to bother with the quadratic formula because I really think this will factor. Now there's nothing common that I can divide out of each and every term, so I'm ready to set up that double parentheses. This tells me same signs. This tells me both minuses. Now there's only one way to split this up. It has to be a 1 and a 1. So we have an x and an x here, and it has to be a 5x and a 1x. This is my only option here. So let's check and see if those outsides and insides will truly create that negative 6x. Out here I'll get a negative 5x. In here I'll get a negative 1x. Negative 5x and negative 1x, do those in fact give me a negative? Yep, they do. So this is in fact the correct way to factor this. I'm just going to clean it up a little bit, give myself some more room. So now remember, zero product principle says if I'm multiplying two things together to get a 0, one of these two is the 0. So either this is the 0 or this is the 0. Now this is a 0, pretty easy, x is 1. If this is a 0, I'm going to add 1 to both sides, and then I'm going to divide by 5, giving me a 1/5. So what this tells me is I have two solutions to my system. In one of the solutions, the x-coordinate is 1. In the other solution, the x-coordinate is 1/5. So now I just need to figure out what the y-coordinate is. I can take these two numbers, I can plug them into either one of the equations, go with the easy one, I'm going to pick the top one. So I'm going to make my x a 1/5 up here. When I plug that in, I'll have 2 times 1/5 plus y equals 4. 2 times 1/5 is 2/5. And so now what I need to do to get that y by itself is I need to subtract 2/5. So I need to take a 4 over 1 and subtract a 2/5. And when I subtract those fractions, I need to get common denominators. The common denominator will be 5. And so therefore, I will have y equals 20 over 5 minus 2 over 5, which is 18 over 5. And does that fraction simplify? No, it does not. Now, don't worry about mixed numbers. Just leave them as impropers. We're totally fine with impropers. So that tells me that one of my solutions is where my x is 1/5 and my y is 18/5. Now I'm going to check out this x equals 1 and figure out what the y-coordinate is for that. So I'm going to take the 1, put it right up in here. So it'll be 2 times 1 plus y equals 4. 2 times 1 is 2. And when I subtract 2 from both sides, I get y equals 2. So my second solution then is going to be x is 1, y is 2. Here are my solutions to the system. Now remember, I need to check them. Checking this one will be pretty easy. I'm going to take my 1 and put it in here. 2 times 1 is 2. I'm going to put my 2 in here. 2 plus 2 is 4. That works. I'm going to take them and put them in this one. Still, even though I'm squaring, it's pretty easy because take that 1 and put it in here. 1 plus 1 is 2. 2 squared is 4. Now take my 2 and put it in here. 2 minus 2 is 0. 0 squared is 0, so I have 4 plus 0, which, yeah, it's 0. So I know that the bottom one works in both. It's a solution. I got to check the top one. That one's a little bit more challenging, so let's give that a whirl. Take that 1/5, put it in here. So that's 2 times 1/5, which is 2/5, plus the 18/5, and I better end up with a 4. Well, 2/5 plus 18/5 is going to be a 25th, and 20 divided by 5, yep, that's 4. So I know that it works for the top one. I need to check the bottom one. Now when I go to check the bottom one, a little bit trickier, take that 1/5 and put it in here. So I'll have 1/5 plus 1 squared plus a 18/5 minus 2. And again, that's squared. And when I do all that, I better come up with a 4. Now here, order of operations says do inside the parentheses first. 1/5 plus 1, which would be 5/5. 1/5 plus 5/5 is going to be 6/5. Now remember, I'm going to square that. 18/5 minus 2, well, let's look at that over here. 18/5 minus 2, the common denominator will be 5. So that'll be 10 over 5. 18/5 minus 10/5 will be an 8/5. But again, I'm going to square that. Now, according to our order of operations, I'll do my exponents before the addition, and I'm going to square the numerator and the denominator, giving me 36 over 25. And here I'll get a 64 over 25. Now I get to add them up. They do have common denominators, so I'm going to add the numerators. 36 and 64 is 100. And what's 100 divided by 25? Yep, it's 4. So I know that this is, in fact, the correct solution to both of them. So the solution to the system, I have 2. Both of these work in both equations. So I hope this helps you with solving systems of nonlinear equations using that method of substitution, very much like the method of substitution for linear equations. Quite frankly, the only difference is you might end up having some quadratics. And you know those 4 methods for solving quadratics, but otherwise it's the same steps as the method of substitution for linears. You're going to take one of the equations, get one variable by itself, plug that into the other equation. That's why it's in all caps. Very important to plug it into the other. That'll give you one of the variables. Take that answer, substitute it into your original equations to get the point of intersection, but be sure that you check those solutions in both equations. I hope that helps. Have a great day.